Hello, it's your web designer from React Finland. Today we discuss GraphQL, and we have three speakers. This time it's a little special session because the speakers are sitting in the same office but in different rooms in Vienna. So it sounds like why are you doing this, but we're doing it. So deal with it. Maybe we do a little round of introductions. So Max, maybe go first.
Sure. I'm Max Stoiber. I am one of the co-founders of GraphQL CDN, but most people know me for having invented a whole bunch of open source projects that are very widely used, like Style Components and React Boilerplate. And I'm actually from Vienna, so I'm particularly excited to be here because I'm sitting in a place giving a talk, which feels surreal. And I'm really excited to be here and speak about GraphQL today.
Yeah, there was a good comment that maybe you should adjust your mic. It's raised up so the people don't hear so well at the moment, but it's
adjust the mic.
Yeah,
quiet.
Maybe adjust your volume a tiny bit, but it's fine. We can go on with the introduction. Maybe Lukas.
Hey, my name is Lukas Holzer. I'm here at Dynatrace, working at Dynatrace, working at the developer experience team. We try to build up like a solid developer experience at Dynatrace. And yeah, I'm very happy to be here. And yeah.
Yeah, and Jan.
Yeah, I'm Jan. I also work here at Dynatrace, also in Dynatrace right now. I'm not from Vienna, but I'm from Austria, from Graz. But I still get the feeling every day because we have a nice view. You can see it from Max in the background. So maybe you have a time for come by. Yeah, right.
Absolutely crazy view. I highly recommend stopping by.
All right. So I guess it's good to define GraphQL first before we discuss more. So what's GraphQL in the first place? What's GraphQL? Why do we have this session?
So I guess I can go. GraphQL is a technology to build APIs with, and it essentially replaces REST, which is what people usually use for APIs and to communicate between service and clients. And really what makes GraphQL special, for me personally, is that it's very tightly specified. And because you have this super tight specification, a lot of people build tooling around it because it's just a standard. And now that more and more people use it, more and more people are building tooling for it that then everybody else can also use because it's standardized. And I think that's, for me, what makes GraphQL really, really special. I don't know, would you agree?
Yeah, totally.
I mean, yeah, it's actually kind of nice that there's so much tooling around it, and the community is just so big that you can, if you have some troubles, for example, if you have some Node.js implementation for the GraphQL, then you just find the answer for it right away, right? So it's super easy. So
yeah, we leverage GraphQL in our conference. So we have a so-called conference API, and on top of that, I have the website, and I do graphics generation and schedules and we had the mobile app at one point. So it was very easy to build on top of GraphQL. So now we're like sort of thinking about the first demonstration. So we discuss GraphQL more or go to the first demo? What do you think?
I will do a little bit of intro in there. So maybe.
Yeah. Okay. So let's go to Lukas' demonstration and get ready.
My talk, automate your stack with GraphQL, is like I want to put a different light on the whole decision, where to use GraphQL, where to use REST, etc. So I want to make you in the feeling of do a decision based on developer experience. So I have a small introduction.
It's just a tiny moment. Your screen is blank at the moment. So
really,
can you? Yeah.
Should I retry to?
Yeah, let's try again. So maybe you can reshare your screen. Then let's just try again. Yeah, it's everything happens live. Everything is especially this time. All the demonstrations are.
Can you
live.
see my screen now?
I see your screen now. So now we're good. Thanks a lot.
So yeah, automate your stack with GraphQL. My name is Lukas Holzer. As mentioned before, I'm working at Dynatrace in the developer experience field, and I want you now to highlight the whole topic with a point of view of developer experience. So when we take a look at the good old REST, it has a big advantage because it's easy to learn. There is no tooling required, and you probably love fetching too much data. The problem is it has a really rusty developer experience, and everything is any. And that's now the particular part I want to hook into. So some people love it, and it's okay. This shouldn't be a judgment about GraphQL or REST. So if you take a look at the GraphQL or REST, so if you take a look at the Louvre and you see the picture of the sheer mass of overfetched data, you probably guess it's not with GraphQL, it's probably with REST. You fetch a ton of data. So, but what is the real problem? What do we want to solve? We want best-in-class developer experience. And we want auto-completion for what you search for. So a developer is highly relying on intelligence. You want typed data. It's extremely important. And a vast ecosystem that is not framework or like language dependent. And of course, you want only fetch what you need and not 10 records more. So good or REST, maybe rest in peace. So there is definitely a new sheriff in town, and this grand sheriff is called GraphQL. And that brings me to the next topic. So if you compare a single REST call to the Swappy API, for the people who don't know Swappy, it's like the Star Wars API. There is a REST API, there's a GraphQL API, and without any fancy tooling, just a plain fetch call, the REST option wins, in my opinion, the developer experience because it's easier to read than the GraphQL. But we have here already one big difference. In the example of REST, we are fetching 10 results due to pagination, and we need 5.9 kilobyte. In the example of GraphQL, we are only interested in the name. So we are getting all the 82 results, but with a total of 1.9 kilobyte. So this problem is still that both have any types. So because we don't have any typing or tooling here, it doesn't help us on the other points of the list. So when we recall what we want to achieve with the auto-completion, we haven't succeeded in there. With the type data, we haven't succeeded. We've only succeeded in fetching what you need. But there we have a reduction by 76%. So how to get typed responses? In my ideal world, I want to write a query. I want to focus now on what do I really want to fetch. So why not write a allpeople.graphql file and say, okay, give me from all people the name. Then there is a magic command. It's called Codechan. And with that, there is something invoked, a tooling, and suddenly there is like a generated TypeScript file with like super cool typings. And because I love working with React, I'm letting me generating some hooks. And these hooks can be used with just a really, really simple data link. And if I now go to my code and if I share with you how this looks like in real life. So I've prepared a GitHub repo. You can have it in the description afterwards where you can go step through.
So maybe you can share the screen again because we lost the screen. So there's some problem.
Oh my God. Sorry.
Yeah, that's fine.
Switching doesn't like stop sharing. Share again. So I hope you can see my screen now. Can you see my screen?
Now, yes, yeah.
Yes? Okay, cool.
Yep.
So as I said, in this case, I've prepared an API with books. So I've here a small project, a small backend, serverless function based on Netlify I deployed, where I specify I have here a small schema where I say, okay, I have a query where I can get a book list with a type of book. And here I have my data JSON where I have like books, a list of books, name, author, description. And of course, a small serverless function that has a resolver that knows how to get or filter those books. But in the front end, what I'm interested in is just querying the parts from a tooling perspective. So I can go here and say, okay, I don't want an author. Let's check what I have here as well. And I get instant feedback what I can really query. So description. If I now go ahead and start my development server, in this case, a simple yarn dev, which will go to a netlify dev command. That's only here for a small demonstration purpose that will serve my functions on the backend. And I have here a second command. It's the Codechan commando. I will start this in the background as well. You see, oh my gosh, I have here my small React app where I can display my results and I can filter by the author. So if I go here with Stefan, I see Stefan Baumgarten has written a book, TypeScript in 50 lessons. And yeah, so I go back and I say, okay, I want instant feedback. What is potentially coming along the street? Oh, then I have to invoke it here. So I have here like a small GraphQL config.js that serves the purpose of local development in my IDE, where I can then execute my schema. And now it asks for a value for the author. I just say, okay, Stefan. Sorry, that's the live demo purpose now. So, oh, the command exited. That's the problem. So I'm because I started the watch command. But the cool thing is the query will adapt and it will automatically generate a so-called fetcher with awesome tabs. And that's not a big point, because when I now hover over what is actually data, I see it's not any anymore. It's like of type book query. And if I go here along and say, okay, what's here? Oh, I get books. And on the books, I have an array here. So probably take the first example, because I'm lazy and I don't want to check it here. I'm just going ahead and say, okay, should have an author. Cool, I'm saving it. This should hopefully recompile the whole thing when my dev server is not flaky currently. And it should present me then an updated list. But the cool thing is now, every API changes, and it changes over time, but your source code probably won't change. So you see, I just get the author. The cool thing now is that when I go back and I say, okay, I don't have an author here, I have only a name or something else here, and I save it, it will automatically regenerate everything based on your query. So really on your query, and it will then provide you with IntelliSense where TypeScript actually fails and say, hey, there is no author on that because there is only name available. And that's for me the key as on developer experience and the key on choosing a communication layer like a framework like GraphQL over REST. Because with REST, I have to manually create my own types that are potentially outdated when the API changes. With GraphQL, I get this nice tooling out of the box that really provides me with the cool sense, okay, now there is no author available. I go here with name. And that's really everything. So it adjusts based on the thing you write and automatically generates those things. So how do I achieve that? I've shown you previously this magical command called Codechan. And all what this is it's from a really awesome group called the Guild. They are doing tons of GraphQL tooling and stitching and everything in the ecosystem of GraphQL. And with that, you install some dev dependencies that are responsible for generating you those files based on the config. And if we take now a close look to this Codechan YAML, which is like the single thing of configuration you need, you see that we specify, okay, we have here some local schemas. It could be a remote schema as well. So in my other example, I have a remote schema. where we can take a look, for example, here with the Swappy. I have no API at all. It's like I only have the Swappy example. I point here to like the official Swappy GraphQL Netlify GraphQL server, and I say, okay, please generate all the types based on that. So if we take a look here, I hope it's large enough. You see, it will hard code here this endpoint for me inside this fetch function, say, okay, method post, there are potential query variables that can be sent. And I automatically generate you all those things as well. So when we take a look back, what does it do? First of all, I get types. I get types for every potential entity on that one. In the case of GraphQL, it's like, okay, I have a film node and tons of typing that is always up to date with your API. Therefore, it's always up to date with your code. And once we look a step further, we say, okay, all GraphQL files that are located under source, like all the documents here, we are going to generate next to the file a TypeScript file with the extension generated TS. And because I really like React Query and what Tanner Lindsay is doing with that, because it provides you a convenience layer on top of like the React hooks for the fetch API, I say, I'm really convinced I don't need any big Apollo library, just using plain fetch with the React Query and just type names. And the outcome is really that they have here a use query hook that has the all people query with the fetcher. That's the function we've seen previously that does exactly that for me. Heading back to the application, it's really easy because I get here like the data, in this case with the all people's query, because we switched to the Star Wars example, and I get even more. So I get like the error is loading, is fetching, so tons of state. And with that, I can really achieve best-in-class developer experience in comparison over a REST API. So when I go back now to an example with a REST API, so I have here a REST API example, and I take a look at what I get back here for the data. You can already imagine it, but it's any. And here, if the API would change or introduce a new field, I wouldn't know it. And if I have to write now a table where I say, okay, I want to display all the names, I really struggle by checking out, okay, what is really the structure of this object? Because is it results or is it result? I don't know. I have to query first the data and I fetch a lot of more. But GraphQL alone won't solve you the problem, because here I have the example of a plain GraphQL API, and that is done with a fetch call. You've seen it on the previous slide. Because you don't need tooling for GraphQL, but without the tooling, data is undefined or any, so you don't have the advantage as well. So in this case, I would rather stick with a REST API than using GraphQL. So in my opinion, the best potential, or why you should choose GraphQL, is probably based on its good type system. So if we go back to the slides, I hope you can see my slides. Can you see my slides?
Yeah. Yes, perfect.
Yeah, so skip that. We've seen that already. We are generating all these files. But when we recall what we now achieved, we achieved now best-in-class developer experience through a really cool tooling system. We achieved auto-completion with a live preview inside the browser. We achieved type data and a vast ecosystem. And I've showed you now an example with React Query, but there are tons of more plugins. So you can use it for Vue, you can use it for Angular, or even for plain JavaScript. So there is no limitation at all. And if you want to build your own plugin, there is even an extension for that you can build your own plugins on top of the whole tooling. And by the way, we fetched only what we needed. So in the end, I guess we did a great job on that one. So if you want to check it out, here are the links. Maybe we can send it in the chat as well. You can check it out on GitHub. And here is like the deployed version. You can just filter So what has Asimov for books? iRobot. Yeah. So heading back to the stream.
All right. Thank you for the demonstration, Lukas. I think it was really instructive, especially for people that don't know GraphQL so well yet. I hope we get some questions during the feed. We got the first one. So if starting from almost scratch, first REST and then GraphQL, or straight to GraphQL, what would you do? Would you write the REST API and then wrap it, or just write GraphQL out of the box?
To be honest, I would really start with GraphQL because, in my opinion, there is nothing that GraphQL cannot cover what REST can cover. So, if you really want to do the journey on your own, you can do it, but you don't have to invent the wheel, in my opinion. So, if you're interested, I guess it's even easier to start developing because you've seen there is so little tooling involved and it provides you so much feedback for writing a better code in the end. So I would advise to go with GraphQL because you cannot have the state where, okay, oh my gosh, I forgot what if this property doesn't exist on my result, and suddenly the whole app broke because you forgot the optional chaining and you accessed the property in an object. With GraphQL, it's fully type safe. And if you use TypeScript, I would say you are safe.
All right, next one. How do you make your API compatible with GraphQL? How do you specify the routes?
I built my API as targeting with GraphQL, and there is only one route, and this one route is called GraphQL. And on this one route, it's like the serverless handler. So with Netlify, you just export one handler, and this handler creates the GraphQL server. So I haven't used even the Apollo serverless or something like that. There are already libraries. You can check it out on GitHub. It's really minimal. So I tried to keep it as minimal as possible. Even with the UI build, there is no Webpack or big bloaty black box build involved. It's like a small bundler called ESBuild, and Netlify does the rest for bundling the functions.
Yeah, so speaking of REST, there's another. Can you use GraphQL to talk to the database? How do you deal with database with GraphQL?
I would say you can do it with GraphQL. There are a tons of tools. So if you check out the tools from the guild, they already provide you a starting point. But on the other hand, see GraphQL as only like the broker of your data. It totally depends on your implementation where you want to gather the data. In my case, I just scraped it from a JSON. But what you put in your resolver, it's really up to you. There are already predefined sets where you have like direct data access, and there are like super starting libraries like Hasura, where you can go into GraphQL development. There are even content management systems like GraphCMS that already provide you like a super GraphQL API as first level thing. So maybe if you want to start with GraphQL, it would be a good starting point to rely on like a solution that already has like a database and provides you like an interface on top of it via GraphQL.
I think a lot of the power of GraphQL actually comes from the fact that you're able to construct this graph from all these different sources, right? And so, as you said, some of your resolvers might talk to the database, but some others might also talk to GraphCMS or any other CMS that you want, right? And you can sort of construct this hierarchical graph of your entire data, no matter where it's from, right? No matter which source it's from, you can just get it and expose it through this unified schema. That's super powerful. And what makes that even more powerful is the Polar Federation, which I'm super excited to hear about later from Jan, because that really sort of adds that extra set of like, oh, not only can you combine all of these different sources, but they can all specify their own schema and can also extend the schema of the others. And so it becomes a lot more powerful. But I'm sure Jan will talk a lot more about that later.
Yeah, that's cool. And how do we resolve queries if you have user-related data, like users have posts and users and posts are in two different tables? Do we always require GraphQL server, or can we?
I guess Jan will target this as well.
Yeah. Okay. So we can leave this for later in the session. Yeah. I wanted to mention one thing about databases and GraphQL. So there is a solution called Post GraphQL. You sort of start from the database, and then it gives you the API on top of that. I will post it to YouTube as well and show it so people can check it out. But it's sort of there are a lot of solutions like this around GraphQL. So that just make it very, very easy to like prototypes and all that. So that it's very, really, really interesting world to explore.
The whole Prisma ecosystem as well. So this is like as well really good example of providing data via GraphQL.
Something I also really enjoyed from Prisma specifically is Nexus, to create the GraphQL server in the first place, because it's based on TypeScript. And if you set everything up front to back with TypeScript, you actually get full type safety from the database level all the way to the client. And so if you remove a field in the database, your client TypeScript will suddenly tell you, hey, you're accessing a field that doesn't even exist anymore. Your server will tell you it doesn't exist anymore as you're exposing the API. And that just gives so much safety to your entire stack. I love working with Nexus. A huge fan of the Prisma folks.
So I don't know if you know this one, but I've used a solution called Type GraphQL for the React Finland API. It's really powerful because you write your this GraphQL declarations in TypeScript, and it just works. It gives you the types. It gives you a GraphQL API. So it's really, really nice for us. So there's a question as well. So your GitHub example is using a pnpm. Can we install with Yarn, or do we need pnpm for your example?
Sorry, you need to install pnpm, but in my opinion, you should already have given pnpm a try, because it's so much faster and better than Yarn. And
All right, so it's
I added a link in the README with where you can install pnpm.
I think GraphQL isn't a controversial enough topic. We also need to get into npm devices, which was the best one, because otherwise, what would this meetup even be?
yeah, of course. And I guess npm is the package manager which you use to install the package manager you want to use. So it's sort of, but yeah, that's another session. Maybe next year we don't touch package managers now. It's too controversial.
But you can delete the pnpm log file and just use Yarn.
Yeah, of course.
Dangerous.
Yeah,
that's where the real danger lies.
Yeah. So let's see if we have. We are sort of running out of questions. So are we ready for the next demonstration, or?
Absolutely.
All right. So next up is Max, and let's get started.
I am so extremely excited to be here. It feels absolutely super weird to be sitting in a room with lights and a camera and be presenting at a meetup again. I haven't done this in 2 years, and it feels really, really good to be here. I'm here to talk about how to edge cache GraphQL APIs. My name is Max, and I am the co-founder of GraphCDN. Now, what most people know me for, like I said, is my open source work. I've done a bunch of open source work in the React and particularly in the React ecosystem, but in the JavaScript ecosystem generally. And a while ago, 3-4 years ago, I was actually building a startup. And this is really where my GraphQL story started, because we were using GraphQL for our entire API needs at Spectrum, which was the startup I co-founded previously. And we were building this modern take on a community forum. So essentially, we wanted to take what PHP BB started 20 years ago, but make it modern again and make it a unified platform. And we were using GraphQL for all of our API needs. And I was the CTO, and we were building this platform out, and we had huge scaling problems because more and more users just kept visiting our product and kept finding it, and our servers and our infrastructure could not keep up. And if you think about sort of a forum, it's really the ideal use case for caching, because all of your data is public, or almost all of your data is public, it's the same data for everyone. It doesn't change, right? Like when you're looking at a post, it doesn't change who's looking at it. It doesn't change what's in the post, right? If you're looking at the comments, those don't change either. And so in my head, I was like, well, we have all of these infrastructure troubles, but really we should be caching our API, right? Like we have all of this data and we had some database level caching, of course, but still we were having infrastructure troubles. And I was like, well, if only we could cache our GraphQL API, then we could really alleviate a lot of the load of our servers. And in my head, even I remember talking to my co-founder, and I even asked this question, like, why can I not just take a GraphQL client, like Apollo client or Urkel or Relay, and deploy that on a server somewhere, right? To rather than caching on the client, I want to cache stuff for all of the clients, just at the server level. And this is really where all of this started. Now, first, let's talk a bit about how actually GraphQL clients cache, because just like the GraphQL code generator that Lukas just so beautifully demonstrated, this is another great example of where the schema of GraphQL is super helpful, and the fact that it's strictly typed. Because the way it works is that when you're looking at a GraphQL query, like here, we're looking at a GraphQL query that fetches a specific post based on its slug. And it's loading its ID and title and its author with its ID, name, and avatar. And the real magic, sort of the fairy dust that makes all of this work is the __ type name meta field, which we can add to any GraphQL query and any object within that query. And the power of that is that it tells us what the type of this thing is, which might sound trivial, right? Of course, when I'm loading a post, I get a post back, and when I'm loading its author, I get a user back. But the client and anybody in between usually doesn't know that. And so with this __ type name field, which any GraphQL API exposes automatically, the result we get back tells us, hey, you've loaded the post with the ID 5 and the user with the ID 1. And they're connected in this way where you have the post and the author of the post is the user with the ID 1. And that's really the magic that makes GraphQL clients so powerful, because when they see this response for the query and they see, okay, we've loaded the post with this ID, we've loaded the user with this ID, they can take this entire response blob and they can put it into the cache. And the next time the same query comes around, they're like, wait, we're loading the post with the slug GraphQL caching. Well, I know how to get you that. We don't need to go to the server. Here's your result, right? And that's really what makes it so powerful. Even more powerful is when you start working with mutations, because GraphQL sort of differentiates between queries, which just load some data, and mutations, which change some data. And because we know that a mutation passes through the cache, we can then know, hey, look, we have an edit post here, for example, that edits the post with the ID 5 to have a different title, how to edge cache GraphQL APIs. Again, we can add the type name field to our mutation response. And then when that response comes back, it tells us, okay, you just sent a mutation. And from that mutation, you returned the post with the ID 5. Hold on a second. I remember I had this query in my cache that also contains the post with the ID 5. Sounds like I might need to invalidate that. And because we know, oh, this was an action that changed something versus, oh, we sent a query that actually fetched something, we can suddenly analyze which changes move through our GraphQL API and update the cache very efficiently and invalidate when we need to. Now, GraphQL clients actually sort of stop at a certain level, which is list invalidation. One of the most, I would say, maybe even annoying parts of working with GraphQL caching is that mutations only work for updates and deletes, but they don't work for creates. And there's a very specific reason for that. If we have a query of posts, so multiple posts in a list, and we get back the response, in this case, we just have one post in our list, again, the post with the ID 5, and then we have a mutation that creates a new post. Now, this creates a completely new object in our database with a completely new ID and also otherwise completely new data. When that mutation response comes back from the API, it doesn't really tell us anything because it tells us, hey, the post with the ID number 6 has changed. But of course, the post with the ID 6 isn't even in our cache dataset, right? We've never seen that post before. All we know is it came back from this mutation. And the GraphQL client basically cannot automatically invalidate our list of posts because there's no post with ID 6 in there. And so what you have to resort to is manual invalidation. And for example, with Urkel, which is my personal favorite GraphQL client, if you want to get into controversial topics again, you can specify these updates based on certain mutations. And for example, in this case, I can configure Urkel to say, hey, anytime a create post mutation, I can configure Urkel to say, hey, anytime a create post mutation comes in, please invalidate any posts query. So invalidate that query that we send to get the list of posts anytime a new post is created. And then the next time that query is run, rather than serving the result from the cache, it'll actually fetch the fresh result from the server, which includes our new post, the number 6, with the number 6. And that's sort of how GraphQL clients work by default. And then there's sort of a more advanced mode. And that more advanced mode is called normalized caching. Personally, I think normalized caching is a bit of a terrible name because I think the name relational caching would be a lot more obvious. But essentially what it boils down to is that rather than caching entire query results for entire queries, they actually take out every single object and normalize it down into a relational structure. And so if we go back to our get post query, which returns the post and its author, and we look at the response, right? We have the post with ID 5 and the user with the ID 1. We've seen this before. Rather than taking this entire thing and putting it into the cache, with normalized caching, you're actually storing each object individually. So in this case, our cache data will actually have a post with the ID 5 that refers to the data for the post with the ID 5, and then the user with the ID 1 as a key that refers to the user with the ID 1. What's missing here, of course, is post.author, which is what connects the post to the user. And so there's a second sort of storage mechanism which connects all of these relations, and it tells the GraphQL client that the query for the post with the slug GraphQL edge caching is the post with ID 5, with its data sitting in the other object, and the post with the ID 5 has an author, which is the user with the ID 1. And that's sort of how it has its own relations table almost. This is literally a little bit like a database. You store each object with its ID completely separately from its relations, and you sort of connect them back together at the end. And the reason GraphQL clients do this is because it actually makes for a much nicer user experience. Because if I know, for example, from a mutation, like we saw before, that the post with the ID 5 has changed, I can now update it in this one central place where I store what even is the post with the ID 5. And any query that has ever fetched that post will be updated automatically. And so the cache can basically update all of the queries at the same time, which is a lot more efficient. And also, where you'll notice this in apps that use GraphQL is mostly with lists. So if you have a list of posts, and then you click on a post, if the GraphQL client uses normalized caching, it can know that it's already fetched the data for the post to display it in the list, right? And so it can actually serve the result of the sort of get a single post query automatically on the client, and then you only have to load whatever else you want to show about the post, right? Like the comments maybe or the likes. And so it makes for a really nice user experience and for a much smarter caching experience. Now, to go back to my original plan, I essentially wanted to take a GraphQL client and deploy it to the edge, right? Ideally, because the world isn't Virginia, right? Most people host their servers in Virginia, in US East 1. It's like the standard place where you put your new servers. But the world really isn't Virginia. I'm in Austria. I have colleagues in Australia. I have a lot of friends across the entire globe, right? And really what I wanted to do is I wanted to distribute our data worldwide so that everybody could access it super quickly. And it should also be cached because I don't want to handle every single request from my server and my database because the data is the same for everyone anyway. So that's where GraphCDN comes in. At the time with Spectrum, this didn't exist at all. And even nowadays, it didn't exist. And so about a year ago, Tim started working on the first version of what became GraphCDN, which is essentially a GraphQL edge cache. And it's not quite as simple as I initially thought. You can't literally take a GraphQL client and deploy it to the edge. It's a little bit harder than that because you have different constraints. Because if you think about what GraphCDN has to do, it's a CDN. So it's a proxy, it's a gateway that sits in between your GraphQL client and your GraphQL API. And it caches stuff at this sort of CDN level. And it does the caching sort of similar to GraphQL clients, and then it also does the purging. But the problem is GraphCDN, when you're writing a GraphQL client, you can assume that it's always for the same user. So you don't have to worry about authorization. If data comes back from the API, you know that the client is authorized to see it, so you don't need to check anything there. You can just keep serving the same data from the cache. This might come in from 2 different users, or maybe even the same user, or maybe there's like 5 different users accessing the same data, and you don't automatically know who has access to what. And so that's why you can't quite take a GraphQL client and deploy it to the edge, but we sort of had to build our own caching mechanism. Now, we built this caching mechanism, and it actually works the simple way. So it takes an entire query and it stores the entire query result. It doesn't do any of the normalized caching because of that constraint, right? We don't know that every person that requests it has access to the same post with the ID 5. We can't just automatically assume that because we're a gateway. And so lots of different users are querying through us, and our cache is serving to lots of different users from the same location. Now, we also know that building a CDN is super duper hard. Building out all of this infrastructure in all of these different locations all around the globe is a ton of work that we're honestly not very qualified for. So instead, we used Fastly's Compute at Edge product. And what Fastly essentially gives you is access to their infrastructure. So nowadays, they have about 60 data centers spread all across the globe, and you can run your own code there. And it's super fast, and it's extremely, extremely powerful. And so we wrote all this caching code to make caching work for sort of at the gateway level. And then we deploy it to Fastly 60 locations. And if you use GraphCDN as a gateway for your GraphQL API, we'll route to the nearest gateway. So for me in Vienna, I know we have a data center in Vienna, and it's just going to use the data center in Vienna. If you're in Germany, it's going to use a data center in Germany. If you're in the US or in South America, it's going to use one. Whatever data center is closest to you. And because we're caching the data and we're serving it super close to the user, it reduces the response time for queries massively. So usually, if you, depending on how close you are to a data center, of course, if you're in Siberia, where there's not a single data center because not a lot of people live there, then it's going to take a little while longer to go to the data center in Finland, I think is the closest one. But since I'm in Vienna, for me, it's super fast, and usually it takes about 20 milliseconds. That's 20 milliseconds to get an API response back from the cache, which is crazy because even the fastest GraphQL APIs I've seen out in the wild take at least 500 milliseconds to serve responses usually. Now, I've blabbed a lot about GraphCDN. Now comes the risky part. I'm also doing a live demo, and I'm going to try to sign up to my own product and give you an example of what it feels like to use it. So I'm going to create a new service for a product that I built called ChangeFeed, which is one of my side projects. And that also uses GraphQL, and it exposes a GraphQL API. And I'm going to create a new GraphCDN service. And then this will spin up sort of instances of GraphCDN in all of these 60 locations. And then I have a proxy, a gateway through to my GraphQL API. And I'm just going to write a very simple query here that doesn't even fetch any data because I'm too lazy to figure out how to fetch data. I'm just going to query the type name. And this goes all the way to my product's GraphQL API. And of course, it's a cache miss because GraphCDN hasn't seen this query before. But now it's actually cached at my local edge location in Vienna. And when I run this query again, it is super fast. It only takes 21 milliseconds to load that same data, and because I get a cache hit. And that's really where the power comes in. You can literally plug this into your GraphQL API, and you only have to change the URL that your GraphQL client fetches from, and suddenly you get all of this caching for free. Now, we've, of course, also done the mutation purging, where if a mutation comes through, we purge it. And we even have a manual purging API, which is, of course, also GraphQL, where you can manually purge stuff. So you have all of these mutations here to purge a user, purge a change, purge an up, purge a release, whatever you want, whatever types you have in your GraphQL API. You can then purge specific users, specific whatever types you have in your GraphQL API. And because we were in this, we built all of this caching logic, and then we were like, wait, we see every single GraphQL query and mutation that comes through our gateway. Why don't we just provide analytics for people, right? And so we've also built GraphQL Analytics. Now, this is demo data because I just created this service. So this is I'm not exposing any real data here, but this is what you would see, right? You would see your requests over time to get sort of a broad overview over how many cache hits and cache misses you get. You can see how fast or slow is my server usually. This is quite a slow GraphQL API with 1.3 seconds P95 response time from the origin. But then you can also dive into specific queries and mutations, right? And I can look at, okay, which queries and which mutations am I seeing how often? What's their cache rate? How fast are they? How slow are they? I can track my errors. I can see all of my GraphQL and HTTP errors that go through the gateway. And then a bunch of other stuff as well. Anyways, that's really what we built and what I wanted to show today. Thank you so much for having me. I hope you enjoyed this talk. I hope you learned something about GraphQL caching. And I look forward to learning more about Apollo Federation.
All right, so let's move to discussion, and let's hope we get some questions. I think it's impressive what built, because there is potential to speed up GraphQL implementations a lot. That's a really good thing.
Thank you.
I
wish this existed 3 years ago when we were building Spectrum. I literally just went, what if this had existed? I would have used it instantly, and it would have solved all of our problems. And so now I was like, well, I kind of want to solve this problem. It's a really big problem, and I know we can help people.
I actually have a question. But Lukas, go ahead, please.
I definitely have to try it out. I haven't known it before, and it's super awesome. It's like Google Analytics on steroids for GraphQL. So alone for the performance insight for the individual queries, insane, really. That's what you need. You want to get those insights. And the performance is just, 21 milliseconds. It's like crazy. 21 milliseconds. It's like crazy.
We looked up recently, and on average, across the billions of requests that have passed through our gateway, we speed up GraphQL APIs at a P95 time by about 150x. That's like an average. That's an average speed up across across all of the requests we've seen, which is absolutely bonkers to me. Like, you just put this in front of your GraphQL API, you cache some stuff, you get 150x improvement in your performance. What? How is that? That doesn't even make any sense.
But I really like that you're using Fastly, because Fastly is really awesome.
I mean, shout out to Fastly, right? Like, we could not be doing this without it. Spinning up all of this infrastructure and making it this performant is an extremely hard problem. And I'm really glad that Fastly built Compute@Edge, because it made our life so much easier. And we don't even have to worry about scaling, right? Like, people can throw however many requests they want at us. It's Fastly, right? Like, Fastly is going to be able to handle any traffic you throw at it. And so I don't have to get up at night due to a PagerDuty alert because our infrastructure is crashing, our servers can't handle it. I know Fastly can handle it.
I just chime in. I have a question, actually, because you said it's caching with the type name and the ID, right? But what if sometimes you have 2 primary keys, right? And it's, I don't know, an ID and something else. What do you do? How do you save it?
Great question. So both GraphQL clients and GraphCDN let you specify something that's usually called key fields. And essentially you can say, hey, for example, in our post example, right, the slug of the post is very unique. And I can tell my GraphQL client and also GraphCDN and any other cache you have, hey, posts are keyed by ID, but they're also uniquely identified by their slug. And then they have some special data structure under the hood that sort of says, okay, if I see the slug X, it refers to the ID Y, right? In our example or earlier, it was like, if you see the slug GraphQL caching, that refers to the post with the ID 5. If you have that in the cache, serve it, otherwise get it from the server, if that makes sense. But that's very configurable. And again, is a big part of what actually makes GraphQL awesome is that it's so tightly specified. And it's surprising to me, and I didn't realize this for a long time, but that's exactly why the ID type exists in GraphQL, right? ID is its own scalar type, its own sort of primitive within the GraphQL specification. And that's actually the reason, because an ID, yes, it could be a string, it could be an int, but really what's important about an ID is that it's unique. And so that already tells GraphQL clients, if you give them the schema, that which are the key fields, right? Because ideally you would have an ID on your slug field and on your ID field, if that makes sense.
So I have a couple of questions from YouTube. Is this available for on-premises environments? So it's supposed,
That's one of the questions we get asked the most, and it's not currently because we're based on Fastly. We very explicitly decided to make sure that we can host this thing at a very high scale before we would even think about on-prem environments. We at first honestly didn't even know if we could make it work, because we started building this and we're like, wait, GraphQL caching actually, if you're doing it at the gateway level, is a little bit more complicated than we thought, right? And so it took us a while to get it right, and Fastly really is a super nice partner because, again, they can handle any scale. I know that some companies have requirements to deploy all the infrastructure on-prem, so that's definitely something we're thinking about, but it's not currently possible.
Yeah, sort of related, why use Fastly and not something else like Amazon and these big dogs?
Because Fastly has more locations, and really what makes Fastly special is the purging. What I didn't really get into, and what is another big part of what makes GraphCDN special, is the super fast purging. If we see a mutation that tells us, hey, the post with the ID 5 has changed, we invalidate any cached query result that contains that post in 150 milliseconds globally. So literally, within 150 milliseconds, every single of the 60 locations all around the world won't have that cached stale data in their cache anymore. It'll be purged completely. And no matter where your users are, they'll go to the origin again to fetch the new data. And that is extremely powerful. And that if you think about any other CDN provider, any other infrastructure provider, yes, you could build this yourself, but there's no way you're building this yourself in any serious amount of time, because getting that down to 150 milliseconds is absolutely bonkers.
Yeah. So I think that's it for YouTube questions for now. We can take more, of course, if you have something in mind, because normally what happens is that we go to the next demonstration and then questions come to mind.
I have one question just to make sure everybody could understand it. So you said it's 21 milliseconds, right? If you have a one direction. Should we disable now local caching, and why not?
That's a great question. I don't think you should, because the local caching does make for an even nicer user experience. Like, it's just instant. And there is a difference between instant and 21 milliseconds. But at least for the initial fetch, the 21 milliseconds is a lot better than 1.5 seconds or even more, right? But I definitely think that local caching makes for a great developer experience. And honestly, it doesn't really come at any cost. In fact, if you use GraphQL Codechan and you combine it with the Urkel plugin or the Apollo plugin or whatever your favorite GraphQL client is, use Urkel. Then
React
you get an amazing you get an amazing developer experience, but also on the other side, you're getting an amazing user experience for all of your users.
All right, thanks.
So maybe we still get ready for the last demonstration of the day by Jan. So
all right.
Yeah, all right. So let's get ready.
All right. So I'm just making sure I'm doing the right screen share. All right, I don't have any presentation prepared right now, but I think coding just shows fine, right? So what is Apollo Federation, and what does it has to do with schema stitching? You might heard of schema stitching maybe, or maybe, of course, only from Apollo Federation. So basically, as you saw before, GraphQL is a very graph-based and edge-based technology. So basically, you could stitch things together, right? So think of it, if there is a subgraph, like you have a user, for example, and it has some items in it, you can immediately add things to it on its way. So I'll show you one simple thing. So for example, if you have multiple queries, this is the Apollo GraphQL Sandbox Explorer. For example, I prepared the me endpoint. So it's just a normal user. And we can fetch the ID and the name. So if we run the query now, we just see the data which is exposed. Also, if we have reviews inside with an ID and an offer, or let's remove the offer from here, just show the ID to make it less verbose. We just see the data. We don't know where it comes from, right? So basically, the reviews with Apollo Federation or schema stitching could come from somewhere else. Because maybe it makes sense that reviews should come from another endpoint, from another maybe REST API where you fetch the data from, or something else. So I can show you how Apollo Federation is solving these kind of things. So basically, you can think of it as a gateway where there's one endpoint for all of them. In our case, I just used the Apollo Federation demo. from the GitHub repo. So there's the accounts, reviews, and products in it. So basically, when I go into the accounts, we can see that there is an extend type query. So it's kind of different because usually you have a type query where you just define some new endpoints and there's maybe some user and it returns a normal user. But this is different because we just extend the query, which means the gateway, which is the central point of all the addresses, just extends the query with the type me. And the accounts endpoint also has the type user. It's when you don't have an extend before, it just defines the type user. What you can see here that if we go back to our Explorer and we go to the type me, you can see that it returns the type user, and inside the type user there's also the reviews. But in the code you see that in the normal type definition there's actually no reviews in here, right? So where does it actually come from? And why does it matter? So actually we have the accounts, and there's actually also the reviews endpoint in here. This is just a monorepo, but separated into each and every own Express server. So on the bottom, each and every file has its own server, which is listening on a different port. So for example, in the reviews endpoint, we can see that there's another extend type user, right? So we just extend the normal type and extend it with the reviews endpoint. But how does it work? So in the accounts, we can see with the type user, we can see that there is another thing, which is usually not in the GraphQL spec. There is the add key with a fields ID. This symbolizes GraphQL or Apollo, that this key can be used as a primary key to extend it for other services. So for example, the reviews is the other service who just extends the user with the key of ID, with the key ID. And also inside of the query, we can say that the ID is external and can also use different and other queries which are now external, which can be used later, which I show you. So how does it work? How can we now say, now we just extended everything, the schema and everything, but the data is not yet really here. So as already Lukas said, there are some resolvers where you can get the data from, where you can do whatever you want, where you can get the data from. We extend actually the user type, which you can see here, right? And in here, we see also the reviews endpoint. And in here, you can do some async work. We can async some data query or fetch or do some data in here. It doesn't matter. The only thing which matters is that we have something in return. In this case, we get the user inside, and and everything which gets in here is now from the keys. So that as you can see, the user is now exposed user.id, and as we also have another external, we can also say user.username in this case. So this is actually a pretty nice technique that we can now stitch things together. Maybe you heard about schema stitching. It's kind of the same thing, the same principle, but schema stitching works on another level. In this case, we kind of stitch together those endpoints on service level. So each and every node server has its own service level. So each and every node server has its own technique to stitch things together. But in schema stitching, everything is on the gateway level. So the central point where we say where data comes from. And in here, there's a stitching technique and stitching endpoints that you do it manually. There's a left join, right join, and whatnot. There are also a lot of tools where they can help you. But Apollo Federation actually helps you on the first place where you just define the type in it. Also, a quick tip, Codechan also supports Federation. You just type in Federation to true, and then you get all the nice tools which Lukas just showed you before. So as we can see now, when I go back to my Apollo Explorer, we can see that the reviews part is now coming from an external service, right? So this is actually the good thing. Also, a very good thing is that you have the type name just built in, so you can use Graph CDN out of the box, and we can relieve our gateway with some cache data, right? So everything is out of the box. Everything is now still with GraphQL. But you can make even more stuff. For example, in this case, we only have the reviews with another kind of object inside, right? But we can make it even further. So there is actually another query you can see. There's not just the me user, but also the top products. The top products is just a list of products. So when I just fetch the name, we can see there are 3 different products: the table, couch, and chair. And there's if the product table, couch, chair is in stock. You can see again, it's just a normal query, but behind the scenes, maybe something is going differently. So let's look in the code. So for example, the products. In here, we just say, okay, we extend the query with the top products. Everything is fine. We just extend the query for the gateway and define our normal product. But it's weird because we just see the UPC, which is the kind of ID here, the name, price, and weight. There is nothing in here with in stock. So where does it actually come from? All right. Apollo Federation got it covered by having the key, so you can extend everything from another service. And we have the inventory service, our Node.js service. So we go into there, and we can see that there is another extend type. So you can't just extend queries. You can also extend normal types of, in this case, product. As I discussed before with you, there's another add key where it just says where it comes from. So in this case, we symbolize that there's the UPC, the kind of ID from this product, which is required, of course. And it is marked as external. So it comes from the original type, which we have defined in the products service. And in here, we can find the in-stock Boolean. So this is what we just saw before in the Apollo Explorer. And I will come to the shipping estimation right after it. So how can we now stitch together those 2 products into one kind of API? So we can see there's from Apollo Federation an own object or an own function called resolve reference. And please mention the underline before. It just symbolizes for Apollo Federation that this one should be used for stitching those things together. So what it does is in the object, there's coming all the fields which I just discovered, which I just marked here as external. So I can use in the object, or I can also write it as product, right? So the product has now the UPC, the weight, and price in it. But for my reference and for my stitching technique, I just care about the unique ID because the inventory, which I just defined above here, just has the UPC ID and some in-stock true false. This can come from an external API or somewhere. In this case, it's just a local thing. And beneath, under this, the normal product comes in, which I just fetched. Plus, I just make a comparison here. I just look into my inventory field and find the current product. So, in the product, I loop over it, and I can see, okay, is the product UPC the same as the object product object UPC? And then I just return it. So now I just made the first stitching here. So the in-stock comes now from the stitch together thing from Apollo Federation. This is actually a great thing if you have a lot of services and a lot of separated node services around somewhere. Yeah. So you can go even further actually. So as you saw, there's also the shipping estimation or shipping estimate as key. So I can define it as int, and there's another thing where it's called requires. So what does it mean? So Apollo Federation goes over it and say, okay, there's the field, and it only can exist when there's the field price and weight. So when you have a new field, you just make a space and type in UPC, which is great. And after having the shipping estimation, you get again the object, so everything which is now in here, which is now defined. And you can go over the price, which you just got from the product itself, and the weight, which you just got from the product itself. So if you don't have that, and if you want to have that, you need those fields, and those are required. And voila, if I go back to my Explorer, I can go shipping is made, run this query, and then I can see, in this case, some fake data. But in the end user don't know where these things comes from. And this is very important for a microservice architecture where you don't know where things come from, but you're just interested in the things that something is coming back. So the right things, right? This is actually very interesting to see. Again, as you could see, there is the server listen. So you can just spin everything up. First, you need the services, and then the gateway, which is again the central place of all the things. There is the Apollo gateway package, and also the class in here where you just define everything. And of course, the Apollo server, where in this case, subscriptions are not supported for now. So they are now disabled. And also you have the gateway in here where you just define the gateway. You might think of schemas, like Apollo Federation said that it's kind of this, or actually the same, and it's a replacement of schema stitching, but it's not entirely true. There's one case where this is not the case. Basically, you can, in schema stitching, you do everything on your own or use tools, of course. But there's actually one thing when you have an external graph from somewhere, could be, I don't know, a demo graph, you can't actually attach it to your Apollo service because it has, as you saw before, the specific type declaration here that you extend, or actually it's better in the reviews, I'm sorry, in the accounts, where you extend the type. So if I just write type, it doesn't work anymore because Apollo Federation doesn't know that it should extend it. So the extend is actually pretty important in here to make everything. All right. So I prepared something to show you about something else. There is actually also, so how does it work now when I deploy everything? In this case, I use Kubernetes to deploy our things. So you can see, I don't know if you ever heard of Kubernetes. It's just a containerized orchestration service, which is also open source and founded by Google, where you just spin up, you have some Docker images and you just spin them up and they run somewhere on your Kubernetes cluster. The Kubernetes cluster is actually where your pods, or actually images, if you want to call it, live. And you can imagine that there is one pod or maybe more pods which can coexist at the same time. And there are some services in between. It acts kind of as an internal load balancer where it just redirects to your single pods and you can distribute stuff. But it's too much right now. So basically I prepared something, some deployments. This is also a Kubernetes scheme right now. So I prepared something where you can see there's the K is just a shortcut for kubectl. Here we can see that I already deployed via Helm my all of my services. So there's the accounts service, inventory node service, products node service, reviews node service, and of course the most important part, the gateway service. So I deployed everything to my local machine, and everything can actually be used under my minikube.dev is just my local host. So I have overwritten it. And on this, there's the GraphQL endpoint, of course, where you can fetch all the data. So there's the GraphQL Apollo Explorer. When you click on it, it's the same as you saw before, where it just queries stuff. So what I actually want to show you is how you can scale your app with Kubernetes with an autoscale, with an horizontal pod autoscaler. What does it mean? So I showed you before that there are, in this case, 5 or 4 services and 1 gateway. And each and every graph comes from another service. So if I go back to my Explorer and go back to go to the reviews and see the author and get the ID. And if I enter this, we have now a deep thing where we actually have a lot of queries from the reviews, our reviews service, our account service, which is the author. And now, if we have a lot of queries on it, it might scale not well because it's a lot of data on it. So basically, there's a horizontal pod autoscaler, which is this case. It's basically just if you have a lot of load on it, and if you don't cache anything, of course, then you get a lot of data on it. And we can say, for example, each and every pod has its own schema. So let's say when I show you the thing here, we say that accounts in this case has 100 milli CPUs available. So everything above will just fail and restart. So let's go into K9S. It's just a little tooling where we can see all of our services with more stats in here. So we see that our deployed service, which is now local, the account service, has a CPU of 11. So if I now query more, it might go up because there's a more load on it. And now I prepared something with, if I open up another terminal window, I prepared now a load test. I use artillery in here. This is just another tooling where there's a config file. I can show you the config file for real quick. The artillery config is just another YAML. I can remove that one. There's just another YAML where I execute the query top products reviews, author, and name. Like here, we define it's for 100 seconds, and 1 second is one request. So now we're gonna execute our load balancer, which is now executing 100 requests in 100 milliseconds, so one request in a second. And if we go back to the K9S, so-called, we can see it might take a while because there's the metrics server behind, which is just tracking the thing. In the meantime, I'll show you, I made a little bug in here, kinda. I have a slow function in my user reference where I just make things slower. So it's basically just a function where I compute things, which is super CPU heavy. So in the meantime, I see during my load test is running, there's an automatic container creation because my CPU went up. It's not yet updated. Maybe I have to go in again. So my CPU went to 150 in this case. And because I defined the horizontal pod autoscaler, I can show you where it's defined. We can see that it's automatic to our CDN. In this case, we got a timeout because everything is running locally and it's super CPU heavy. There is still everything running and it's automatically autoscaled the accounts, which is actually pretty nice to have. It's not updating the CPUs in here, but if I restart everything again, it's automatic. You can see that there's the CPU load and goes back. So right after so it's already 1 minute and 31 seconds. And if I wait a little time, you can see that the timeouts went away because my Kubernetes thing automatically updated everything from the horizontal pod autoscaler. And after a while, which is soon over, so I made it for 120 seconds, which is 2 minutes. So it should complete now. In this case, I had 19 timeouts, which is the output here, the summary of artillery of our load test, and there are 101 requests which were fine. So in total, it's 120. And after some seconds, you can see that there are 4 new pods running. So four services at the same time. And after a while, they just spin down when there's no more load on it, and it just went down. So just a real quick sample on how it looks like. The autoscaler with the new V2 beta 2, you have a new behavior field where you can define when it's scaling up and when it's scaling down. In this case, I said that there's the policy with 50%, and it gets the data every 15 seconds. So that's why it took some time. If I make it to 1 second, it fetches every time and see, okay, is the CPU to 50 already? And we also define how many pods, so how many node services there are at the same time, and just spin them up to 5. So we can control our billing, of course, because this is the most important thing. We don't want to scale up 100 services in case of, when there's a memory leak or something, the CPU also goes up, or the memory, of course. Then we don't want to spend up all the things. And also there's the scale down. So we say, okay, if there's 10% of the CPU load within a window of 0 seconds, so as soon as you get it, please don't use this in production, because usually you should wait for 5 minutes because there could be another load on it. But still, this is the way how autoscaler works. And you're just safe after a while. So actually, which is also quite nice, which I just configured in my Kubernetes cluster, if I go back, we can see that I also introduced some kubemons in here. So from Dynatrace, which is running inside my Kubernetes cluster, which is also running locally right now. So everything right now is now monitored. So we can see the last 30 minutes. And we can see a little spike in here, which was just before here. And when we go down, we have some events where we just scaled up, or like in this case, we see that the accounts deployment has scaled up to 2. And if we go up, we also scale down there. So if we go even lower, we can see, today at 9:12, we scaled up the replicas. The replica is just how many pods or how many node services in this case run at the same time. And there is even more scaling up to 3. And right after some time, it's stopping all the accounts, services, and scale down and scale down. And we can also set some problems in here. So Dynatrace can send you a Slack notification. And we can analyze the problem if there is some. But in our case, we know, okay, it's the slow function. We can analyze the problem if there is some. But in our case, we know, okay, it's the slow function. We can also determine it inside Dynatrace where the spike was. And we can analyze it even deeper. So to make it even more Reacty, because it's React Finland, this is the React homepage, and this is everything what I have. Thank you.
That ending was amazing.
Let's wrap up. It was a lot to. I think I have to watch it again, because I never do this Kubernetes stuff. But yeah,
I loved it though. I loved it. I think Apollo Federation is super powerful. We've talked to dozens, if not hundreds, of people using GraphQL, and a lot of them are actually using Apollo Federation, particularly at the bigger size. Like when you get really big, it's a really nice way to split things between teams, and their tooling around it is really, really good. So excited to see this happening, and how well it works with Kubernetes is amazing.
Yeah, I mean, it's actually pretty nice to see how it works with different teams, right? That there are different teams that can focus on their own stuff, and you just deliver the thing what you do, right?
Yeah.
I only knew it. Sorry.
Yes, sir. Go ahead.
Yeah. I only knew it from like the GraphQL mesh, where you can connect like multiple resources like REST APIs, GraphQL services together, stitch them together. But this, what you showed with Federation, was really powerful. So really stoked to see this somewhere in production.
Yeah, so we have a question. I think this is from Max, but you can respond, and Max can respond. How many concurrent requests can be managed like this way? Because
it depends on how much money you want to spend, right? So there are a lot of load balancers which can handle a lot of things concurrently. In my case, I can't use that much because I have locally just limited resources. So I'm running my local Minikube, so my local cluster in here, which has 4 CPUs. And I only have, I think I can manage locally 2 requests per second. And that's the limit of my local machine. But of course, if you go to the cloud, you can spend like, there is no limit.
Fastly, just so I keep raving about Fastly, handles about, on average, I think 20 million requests every second. So a lot more than you'll hopefully need. And I don't want to know what amount of requests they handle at peak times. It must be crazy.
Yeah.
Yeah.
So this is this is actually insane. How many requests you can have, and how you can scale. And actually, it's pretty nice if you have a CDN, for example, that you can get those requests and just make it even faster for them, right?
Exactly. Why did you mention that? I wonder.
I don't know.
But so because there are no more questions, maybe we can go through some takeaways from the session. So what did we learn, or what are the things to take home?
I guess
Actually,
sorry.
Go for it.
I guess don't waste time on waiting for query results. Use a CDN.
I actually think my takeaways were GraphQL Codechan, freaking awesome. Best thing since sliced bread. Literally, if you were using GraphQL, use GraphQL Codechan. And my other takeaway was Apollo Federation and Kubernetes play super nicely together. Use that combination as well.
Yeah, actually, it was pretty new to me. Not the Codechan in general, but the plugin with React Query. I didn't know that one. It's like super intense what you can get, right? Because I always used React Query, of course, but I only used Query, and then in there I fetched everything. So there's the use mutation and everything, and then I just put the generic in there, which is generated, but actually the plugin is actually amazing that they have that. So this is my takeaway, of course. And of course,
I mean, the main takeaway has to be use Graph CDN. I mean, that just has to be the main takeaway.
Probably decide because of all the three aspects and combine all the three aspects at once.
Exactly. Yes.
Also, so I think a big takeaway is always be prepared for a lot of users. If you have some startup or I don't know what, just be prepared that maybe tomorrow is your day, and tomorrow, it just needs to be scaling. So there's the tooling, right? If you want to scale, you need to be fast. You want to deliver stuff immediately. And then if there are more users, you also need a lot of data and analytics, right? So I think Dynatrace comes in place to pretty nicely. You have analytics. Also with the analytics from Graph CDN, you just know where you should scale up. And I think this is the main takeaway of GraphQL or from this talk.
I mean, one really good takeaway is, in my opinion, that if the next situation is where you have to argue if GraphQL or not, I guess you got now tons of arguments why yes. So it starts from the developer experience, heading up to like the speed and then to the scalability. So if anybody says GraphQL is slower or has worse performance than REST, I would call it a bullshit, to be honest.
Also because of the nicely quote, "Rest in peace," which I like the most.
Sorry for really kind of dead jokes.
Yeah.
Actually, what I wondered, you put a sheriff patch in it. Does the GraphQL or the GraphQL logo comes from it? Because it looks exactly the same.
It just matches up perfectly.
Okay.
All right. So I think you will find some sandwich or whatever you have at the menu. I have sauna waiting.
Nice.
So yeah. So I guess we wrap up and say goodbye.